So I wanted to show an extension I built for Ableton Live that solves a problem I had a few weeks ago when I was building a sample library. And what happened is I had a file with samples, and Ableton identifies the transients, right? Or where the sound starts. But it doesn't allow you to cut it automatically on the transients, this clip, so I can use the samples for my instrument. So I ended up doing this manually, and it took me forever. And when the extensions SDK came out, I was like, oh, I could have done that writing some code and saved so much time. So I'm just going to show you how I build that tool. Let me get it to run. Here, I called it the splitter in my extension file. So I'm just going to run it and connect it to Ableton. Right there, I know it's connected through that console log that I have in my code right here. And then I can go to the clip, find my extension, and there it is. And I'm gonna apply it and check that out. So what this extension did is it cut the clip in all the transients. So now if I'm building an instrument, I could just grab these and put them directly into my instrument rack or drum rack to build my sampler. And I just wanted to show you how I did this, not as a tutorial of how to write code, but more like how I approached the problem, how I broke it down, with the purpose of a lot of people that want to use these extensions are maybe know a little bit of code. They're technical people for the most part, but maybe they have limitations. So by sharing this, I wanted to show how I went around my limitations. As a bit of context, I'm a web developer. I know how to write JavaScript and TypeScript code, which is the scripting language the extensions SDK uses. But I'm not a master of Ableton, and also I'm not an audio programmer, meaning I don't write algorithms to process audio. That's above my paycheck, so to speak. I've tried it and I built some things with Python, but it's really something I don't master. So I was able to do this by breaking down the problem and assigning it to different combination of my skills and AI to bring it about in a way that it's manageable, where things don't get out of control when I use the AI. So yeah, let me run through the code and how I approach this problem. So if you've set up an extension, you pretty much have this file right here that's called extensions, and you put in your code. This is the entry point from Ableton Live, right? So I'm gonna start from the activate function, which is the main, and I'll explain everything that's happening here. But the first thing I do before start writing code is I pseudocode. I break down the problem in my head so I know how to approach it. What do I have to do if I want to break this file into clips? So the first thing, obviously, is I need to identify the original audio clip that I'm using, right? And I need to find it in the file system of my computer. So that's one first thing I would do. I said find file and turn it to sample array or list. Array is just a data structure that all programming languages have, just a list of things, right? In an ordered list. So next step, I have my file. What do I need to do with that file or that array of samples to identify the transients? And I'm just gonna put here, right here, detect transients. That's the second step, like how would approach it globally to divide my code in different sections. And so I need to process that so that I can make the cuts right here on those places, right? So step number 3 would use transient array to cut clip. And that's the main functionality of this, right? So, okay, let's start looking at this activate function, which is the entry point again from Ableton, and go through these steps. I already wrote them down so you can see them. So the first part, it's kind of the boilerplate. You have to initialize the SDK, and this creates this context object, which is basically a code representation of the Ableton software state. And it has a series of elements that you can interact with. Since it's written in TypeScript, and if you're using VS Code, you can hover over this and you can see the type. And if you press Command and click, you can go to the type definition. That's a very useful tool if you need to figure out how a particular object, what options it has. So right here, this is kind of a boilerplate where you take the application and you take the song, which is your session, and you extract the current tempo. And here you're just printing the tempo to the console. Then second step is registering the menu action, which in this case, it would be this thing right here, right? So I need to add a menu action to an audio clip so that it shows up when I right click and I look at the extensions menu. So this happens right here. I extract the UI element from the context and I register context menu action. I'm telling Ableton, hey, add a menu action element. And this takes 3 parameters. It takes the scope it applies to. So in this case, it's audio clip because I want this extension to apply to audio clips. So I define it right here. If you see the hover over the method right here, you'll see over here what it takes as parameters. So scope, which is the first parameter, takes all of these possible elements. In this case, I need audio clip. The next element is title, which is a string. And I'll just assign split stem, which is the name I gave it. If you go right here, extension, you see split stem. That's the label you're using for your action. And the third is command ID, which is a string. So this would be a unique identifier for the SDK to recognize this particular context menu action. So I just named it split stem with a camel case right there. So the next step here is registering the command. What is the command? The command is the instructions that will be executed when you select this particular element. You click right here. So what will happen? You're telling it, okay, split stem, I'm registering this command, and this function, that is the second parameter of this registered command method, is what's gonna get executed. So all this thing is the action that happens when you click. Let's look at this register command. And here's where I break down the problem, right? So the first thing I do, remember, I need to find the file and turn it into a sample array or a list. I have the instruction right here. This goes really up there. So the first thing, I need to get that clip. And this is a method that the SDK has to allow you to find an element and interact with it. So in this case, you get the handle as this param from the async function. And what handle is just an object that has an identifier. It looks something like this. And it will have some kind of ID here, whatever, which is the unique element that you're referencing in Ableton Lite. In this case, it will be this clip. So let's go back. When you select this element and you click here, you're referencing this audio clip, and this is the ID that will come in the handle, right? And it has kind of this structure. It has an ID that identifies that specific clip, and then you can get the object to manipulate it with this method get object from handle in the context. Then you pass the type of what this is. That's one of the elements that it takes as a parameter right there, type. And right there, I have my clip as a variable that I can manipulate. So what's next? I need to find this audio file in the file system. So the first thing, unfortunately, the clip, if you see here, I'm gonna hover on audio clip, the type, and we'll see what kind of properties this audio clip has. And I see, oh, it has a file path. So that's where the file, the original one, this one, sits in your file system. So I'm gonna get that and I'm gonna assign it to a variable called file path. So with that information, I can then go and read this file. So this line of code does two things. First, let's break it down. And this I took from one of the examples that come in with the SDK. I believe I have it here. So this one, strip silence. This is an example that comes with the SDK. This is an extension that removes the silences from a clip. So I know this one is going to read a file because you need to read the file to analyze it and find those silences. So I know somewhere around here there's both the opening the file and processing it. So I can see it right here, right? I know, oh, it's reading the file and then it's decoding it. So I just copied that, and what I figured out, okay, these are methods, right? So I'm gonna look at the, what is this, FS? Okay, it comes from a package called FS, which stands for file system, and I believe that comes with the default installation Node.js, so you don't need to install it as a separate package. And then there's this decode audio. What is this? Okay, there's audio decode is, I believe, an external library. So the way you can check that, Node projects have this package.json file, which establishes both the scripts that you use to run the program and the dependencies. Dependencies are all the software you use. It's built on other software. In this case, this particular, of course, uses the Ableton SDK, which is what we're using, and audio decode, which is an external library to decode audio. So the way you would do that is you would simply, I'm not going to run it, but you would go to your root directory in your project and you would do like npm install audio decoder or decode. So you would run this thing. And so going back to the splitter code, now this line of code does two things. One, it reads the file, uses the file system package and the read file method to read the file from that method. And it does it asynchronously. That's what this await does. It's telling this is not something that happens right away. We need to wait for it, because this is a process that takes a while. So what is happening is when this line of code executes, it waits until it's complete to continue with the rest of the execution, right? So what happens? This function right here generates an output that it's gonna be a file, an audio file, and then we're gonna pass that to this decode audio function from the decode audio package. And this will spit out again a decoded audio file, which is, in this case, it has an audio data type. And now that we have that, and this I took from the example too, you create an array from the channel data in that decoded object. And that's how you get this other object called audio data, which contains the arrays of samples. So we've completed get audio file and turn it into a sample array. Now, the other piece of information you will want to extract is the sample rate, because like any audio processing will require you to specify the sample rate of the file you're using. And in this case, audio decoded already provides that information. So I store it in this SR variable to use it later. Now, second step, we have our array. We need to extract the transients. So this is where the limitations of my developer skills came in. I have done this. I know I can do this, but implementing a detecting transients algorithm would require me to go read a bunch of stuff and understand how you can detect transients. There's likely many different ways of doing it. I would have to pick one, understand it, and then come back and start writing the code to process the samples. That would have taken me 3-4 weeks, I don't know how long. And I don't have that kind of time. So this is when AI becomes really useful. It's true that I could have used AI to build this whole thing, but the thing with AI, and especially now that it's getting more expensive, is I don't want to use it on everything. I just want to use it for specific tasks. I don't like when I don't know what I'm doing, because I know it's gonna come bite me in the ass later when I need to debug it. And if I don't understand anything, it's gonna take me forever to figure out what's happening. So I just want to be very deliberate or where I use AI. So in this case, this is the place I used it. I abstracted the detect transients as a function, and I'm just calling it. I'm giving it the audio samples and the configuration options that we'll look into in a second. And then I just get my transients, which that's gonna be an array of numbers. We'll go into this function exactly, but this is so detect transients. We know that happens, and it gives us back a number array. Step number 3 is take this array of numbers, which represent the transients right here, right? These guys, and cut the clips. Now, this is something I had to like brute force to understand how it works. The documentation from Ableton it's not very clear on this, but I realized that by looking at one of the examples, especially this one, strip silence, that cutting a clip doesn't have at the clip level, it happens at the audio track level, which is not this object, right? It's this one right here. So I needed to find, how do I connect this clip to the audio track that contains it? As I said before, this is not super clear in the documentation of the SDK, but the parent of the clip will be the audio track in this case. So what I'm doing is saying, okay, Ableton, I have this audio file. I need to find the parent track of this audio file so I can chop this clip in the places I need to. So that's where this line of code comes. I apply the same get object from handle method that we applied for the clip, in this case for the track. And it's the same thing. Parent has a handle property, which is the same kind of object that's an ID that identifies this unique track in the Ableton session. Clear? Cool. So we have the track. Now let me skip a few lines, and this is where the cut process happens. So I'm gonna take my transients, which is an array of numbers, and I'm gonna iterate through it. Iterate means go one by one in order, right? So if I have an array that's 1, 2, 3, 4, I'm gonna just go first process 1, then process 2, process 3, process 4. There's many ways of doing this in TypeScript, JavaScript. There's for loops, there's for each method. I use this map one, which is a little cleaner. So what this does is it will execute this function for each element in the transients. So when I do transient.map, each element on that array, or each transient marker, it's gonna be one element. So what I'm gonna do is the start, I'm gonna define it as transients and then divided by beats per second. This is a little kind of gotcha that Ableton has. The transient itself, you don't pass it raw, so to speak. You have to divide it by the beats per second, so Ableton knows where exactly the cut is. And then I define the end of the cut as transient plus 1 milliseconds. So if you can see here, then I'm making a cut that is, so you see that gap right there, that's the 1 millisecond right there. So that's how I do it. And then I use this clear clips in range method from the track object, and I define start and end as parameters, and that's what executes the cut. So if I were to execute this just like that, this would create the cuts, yes, but it will create them as individual actions. So if you wanted to go back, so to speak, of Command Z, you would have to do it 100 times to cut this file. You would have to do Command Z 100 times to go back to the state you were before. So this is a kind of a neat thing, this wrapper called context within transaction. So what this does, it wraps all these executions into one transaction that can be rolled back with just one rollback, not 100, right? So yeah, that's what it's happening. And then this returns a promise, which I'm not going to go that into, but this is like asynchronous functionality of TypeScript. But basically, I store all those cuts in this promises, and then I call this promise.all that will execute all of these. So what's happening here, we're not really executing the cuts right here, we're storing them as instructions, and then we execute them right here with the promise.all method. And regarding the beats per second, this is something you can figure out from the tempo in the session, and you just divide 60 by the tempo, and you'll get how many beats per second there is. And you need to do that math to get the exact positions of these things from the millisecond precision of the transients. And yeah, that's about it. So that's the broad part of it. Now let's go into the detect transients. This is where I used AI, right? So I can more or less follow this code. It's using this FFT library, which is a fast Fourier transform library to process audio, and applying a bunch of math to figure out where these elements are. So as I said, I could have done this. It would have taken me a long time. Then this is where AI is really useful. I don't need to figure this out on my own. I can just like constrain the problem and use AI to solve that specific function, which is detect transients. What I will point out here that it's important is the parameters this function takes. It takes the samples or your audio clip turned into samples, and it takes this transient detector options, which is a type that has these elements. Transient detection algorithm that Claude came out with takes these parameters. Sample rate is how many samples per second your audio file has. You want to determine this dynamically with the SR, because depending on which audio file you have, it's going to have a different sample rate. And you know, Ableton allows you to drop different sample rates on the same session. It's very flexible with that. So it's better to handle it programmatically than hard coding it. I'm going to close this guy there. The other side is the frame size, which frame size is like the size of the window that you will analyze at each step. Because you know your audio samples will be like an array of numbers, right? And you want to determine how many samples you will analyze at a time. Because to detect transients, you don't analyze one sample at a time. You need to analyze a bunch of samples and how they relate to each other. And then the hop size is, say our frame size is 2, then the hop size is how many elements it will jump for the next analysis. Then the threshold is, what is the threshold for the transient to be detected? Like, the idea is the higher this number is, the less cuts you will have. And finally, minimum gap in milliseconds. Once you identify a transient, say there's another transient here, but if it's closer to 50 milliseconds, it will ignore it. And the idea of that is preventing like transients that are very close. Like say you're recording a snare and the snare does like a ghost note, like da-da, da-da, da-da. You don't want those two transients to be cut in different places. You just want one sample. So this allows you to configure what is that minimum gap. So, and right here it has default values. That's the syntax to define default values, but I'm not really using these because when I call detect transients right here, I'm passing these options, which I defined in the extensions file. And what's gonna be really neat, and it's something I haven't implemented yet, is I'll build a UI basically to manipulate these with a slider. So I can play around with the frame size or hop size, but mostly with the threshold, I think, or the min gap. So yeah, as you can see, some of I have strong knowledge of certain areas of this. There's other areas like this audio processing stuff that I'm not really good at, but by breaking down the problem and using AI deliberately in certain areas of that problem, I could come up with this cool little extension that's very useful.